Everyone, welcome back to another hardware news recap of the week. In this one, NVIDIA being investigated for monopolistic practices, but not by America. It's by China, actually. Also, there might be signs of an RTX 6090. Intel has so-called super cores that can wormhole jump actual terms in an actual patent filing, by the way, with the USPTO, and AMD marketing 1000 FPS gaming with its X3 CPUs, and not a green screen, by the way. I will not expand on why I'm here. Before that, this video is brought to you by the Height Y70 Touch Infinite. We previously reviewed the Height Y70 non-touch series and found its overall build quality to be good and competitive. Now, the Y70 Touch Infinite ships with a custom 14.9-inch IPS touchscreen with a 60Hz refresh rate. The screen connects to your system build and can be used as a showpiece on the angled corner front panel, displaying stats, music players, videos, and more. Height's entire Y70 series now also includes multiple new colors, like the Taro model that you're seeing here. Learn more at the link in the description below. Now we're going to talk about Intel's wormholes. That sounded wrong. Intel has filed a patent for what it's calling software-defined supercores. It seems like Intel wants these so-called supercores to be its next evolution of design. This is kind of in the topic of things like hyper-threading, P-cores, E-cores, stuff like that. And we would assume that their next cores will be called Super TI cores. But the patent was filed actually December 2023. It's just been published recently this year. And we took some time to read through the patent filing and have put together our best understanding, at least based on what they've published, on what is being developed by Intel for what's coming up next. The basic idea is that supercores are a virtual fusion of two physical cores acting as one, as far as the operating system and the software are concerned. In this regard, it's kind of like the opposite of hyper-threading. And so we would propose, Intel, if it's not too late to amend your patent filing, just a recommendation, you should call it hypo-threading instead. I'm sorry, I will leave now. In theory, hypo-threading would enable Intel CPUs to accelerate the execution of single-threaded processes more efficiently and potentially faster overall. Intel posits that the traditional approach to high-performance cores that have a very high frequency is inefficient in performance per watt, which is definitely true in our testing. This leads to Intel building continually larger, high IPC cores with a high degree of dependence on the fab process technology that they're actually produced on. Larger cores also have a die area cost, taking up more space and reducing the number of cores for a given die size. So to us, the patent filing kind of sounds like Intel is recognizing the forthcoming problem, which is that the runway is running out for them to continue taking their traditional approach of bigger cores, faster, more power, to try and solve performance problems. Intel also says that the traditional method of multi-threading software to run across more than one core ends up creating 25 to 40% of instruction overhead over the native program, which is itself inefficient. Now, the patent filing is very technical, but it contains some pretty digestible sections that point us toward what Intel is trying to do here. Quote, software-defined supercores, or SDC, seek to aggregate the instructions per cycle, or IPC, capabilities of neighboring cores into a supercore. A supercore is a virtual construct grouping of two or more cores, in some examples physically adjacent core, that are virtually fused such that they each run different portions of an application's instructions, but retire the instructions in original program order. Thus, the virtually fused supercores gives the software applications and/or operating systems the semblance of being a single core. A supercore enables energy-efficient, high-performance capability at the same voltage and frequency, end quote. Intel goes on to say that software-defined supercores will reduce the, quote, traditional process technology node dependence on scaling core size, end quote. I read into this pretty plainly. It's good and it's bad. It's good they're trying to solve a problem that they've found themselves with. It's bad because they're admitting that there's a problem that they need to solve, which is that Intel's fabs are no longer the most advanced on the planet, and it is struggling to keep pace with TSMC. Intel is using TSMC to make its own products now. That narrows its margin. It kind of becomes a potential death spiral as they attempt to compete in just making CPUs by using the competitor who makes the CPUs of their CPUs competitors. And so this may be an attempt at trying to solve that by reducing the reliance on the most advanced fabs to make products. On a more technical level, the first core in the supercore cluster would get the first instruction set from the single-threaded program. Then, simultaneously, the second physical core in the cluster would get the second set of instructions, allowing the cluster to execute on both the first and second set of instructions at the same time. Figure 4 of the patent shows a simplified version of how program instructions flow in both original and modified for supercores format. Apparently, it involves a wormhole. And no, we're not kidding, that is Intel's name for shared address space. Do you see what I did? Instruction skipping is done with, quote, unconditional wormhole jump instructions, not shown, which steer the core to skip the next code segment, end quote. Well, first of all, this is obviously a huge disappointment because when it comes to, quote, unconditional wormhole jump instructions not shown, end quote, we really wish they had shown it. Because we'd like to see what unconditional ones look like. I mean, we, at GN, we see conditional wormhole jump instructions all the time. They're pretty common. You probably know what they look like. I'm sure we don't need to show you what those look like. So we'd like to see the unconditional ones. There's also a rudimentary drawing of what a supercore would look like in a block diagram form. No, wait, that's what Intel's fab team was drawing when they got laid off. But this is the rudimentary drawing for the supercores, where two neighboring cores beside each other are shown virtually fused together into the supercore. The rest of the patent and drawings get even more opaque and require deeper knowledge of processor microarchitecture to grasp. They describe the way scheduling and branching would work and how execution order would be enforced. One other interesting thing here is that the operating system could monitor how well a program is running in supercore mode, and that it could switch it back to standard single-core mode if necessary. Intel gives the example of branch prediction repeatedly failing and actually incurring a penalty rather than a speed up. So zooming back out, it seems like Intel wants this to be the next big step beyond Arrow Lake's abandonment of hyperthreading for streamlined high IPC P cores and stuffing it with E cores to win back multi-threaded performance. The supercore concept pushes the streamlining further for software that doesn't benefit from traditional multi-threading. It comes across as a bit of an identity crisis for the company that has made a lot of changes in its approach over the last several generations as it's scrambled to keep up. But if an identity crisis is what it takes for Intel to get back into the game and to remain at least partially competitive, then we're all for it. Obviously, it wasn't working out before. So another big part of this is for Intel to improve efficiency, where it's trying to hit the same or higher performance targets while using less power. We saw that begin with Arrow Lake. That actually wasn't intentional. And they had some regression as a result. Intel needs to keep pushing on that, though, to have any chance of advancement and competition. And it seems like they're trying to keep the cores within their more efficient band on the volt frequency curve. There was some talk in the patent about how having two different types of core in the same CPU is inconvenient, which is what Intel does now. Supercores would allow Intel to stick to just one core type within the same die. It's what AMD does with its modern consumer CPUs as well. Although AMD uses simultaneous multi-threading, Intel had a version of that it called hyper-threading, and supercores seem to be going a more physically based approach entirely. That all sounds great in theory, of course, but at one point, Intel thought it was going to be able to push all the way to 10 gigahertz no problem. That didn't work out, so we'll see if supercores make it into any future Intel CPUs and if they actually help, or if it's all just theory. But when we were pulling a source for the 10 gigahertz citation, we ran across this in that story. It's a very interesting and fun excerpt from the same article that we couldn't pass up sharing, thanks to archive.org for preserving it. Quote, imagine being able to speak normally with your computer as you would a secretary sitting next to you, and you have your computer accurately and quickly take notes from your speech. Imagine logging onto your computer, not via a username and a password, but by sitting in front of your display and having it scan your face to figure out if you are allowed access to the computer. It's definitely going to be a bright future if this does hold true, end quote. Yes, imagine. Just imagine how great that would be. And how, look, okay, we forgive young Mr. Shimpy for thinking that would be a bright future. He didn't know we were gonna end up here, okay? It was like 2000 when he wrote that article. We can forgive him for the optimism. He probably had just seen The Matrix or something. Up next, NVIDIA may have already shown off what could become the 6090, but more interestingly, 128 gigabytes of memory. NVIDIA just unveiled its next-gen Rubin CPX GPU, which NVIDIA says is, quote, purpose-built to handle million-token coding and generative video applications, end quote. It's intended to complement the previously announced Vera CPUs and Rubin GPUs that will make up the larger systems used for the really big jobs, like training models. This Rubin CPX configuration will be equipped with 128 gigabytes of GDDR7, and NVIDIA rates it for 30 petaflops of NVFP4 compute. It also has 4 NV encoders and 4 NV decoder engines, which would make it good for video editing and rendering work. NVIDIA published a die shot of Rubin CPX among its presentation materials. High Yield noted on Twitter that the Rubin CPX die looks, quote, similar to GB202, end quote, and identified structures that look like raster units with up to 256 ROPs. Naturally, the up to 256 ROPs is because some of them just might not be there. High Yield also spotted what they called a large L2 cache, estimated at 128 megabytes, and 4 display drivers. Now, some of these features are things that NVIDIA's true HPC or so-called AI-only designs don't tend to waste space on, and so it's possible that NVIDIA wants to keep the door open for Rubin to become a workstation product or maybe a gaming product. Historically, the example to look at might be Volta, which only made it to desktop machines by the way of the Titan V, including the CEO edition with the stupid champagne color gimmick. It also made it to desktop by the Quadro GV100. Pretty much everything else from that era was intended for more server type uses, and it didn't make it in any kind of gaming product. So sometimes they do that, they segment it that way. Regardless of what product it becomes, Rubin CPX isn't slated to launch until possibly the end of 2026, based on NVIDIA's present roadmap that it has shown publicly. All right, up next, we have a couple quick updates on the NVIDIA GPU trade situation. Last time we checked in on the status of Schrodinger's GPUs, the White House had just stated that NVIDIA's H20 GPUs and AMD's MI308 GPUs would be permitted for sale to Chinese companies if a 15% cut were given to the US government. Now, from what we can find, this hasn't been disclosed or updated in the most recent filings from the companies, which would indicate that it hasn't materialized yet, hasn't been put into place yet, or it's not going to happen, but that was the news as we had it most recently. The last couple weeks, the Financial Times reported that China's Cyberspace Administration had imposed restrictions on the ability of large companies, ByteDance and Alibaba in China, to purchase NVIDIA GPUs. The Financial Times reported that this could affect tens of thousands of purchases of the RTX Pro 6000D. We previously reported that the same agency in China, in conjunction with state-backed media, had raised concerns over potential backdoors and tracking devices in NVIDIA GPUs, which NVIDIA publicly denied in a post entitled, quote, no backdoors, no kill switches, no spyware, end quote. The Financial Times is reporting that the regulations have pushed China to move faster to build its domestic solutions. Around the time of his trip to the UK with the president in the last couple weeks, Huan is quoted by CNBC as stating, quote, we probably contributed more to the China market than most countries have, and I'm disappointed with what I see. The Chinese market is important. It's large. The technology industry is vibrant. We've been in service of it for 30 years, end quote. CNBC cited Huan as stating that NVIDIA would, quote, continue to be supportive of the Chinese government and Chinese companies as they wish, and we're of course going to continue to support the US government as they all sort through these geopolitical policies, end quote. Separate from this, NVIDIA is under an investigation from China's State Administration for Market Regulation, or SAMR, similar to the US FTC. This is after China says a preliminary probe found the company to be in violation of China's anti-monopoly law, citing the Mellanox networking hardware rather than the more expected GPUs. Quote, recently after a preliminary investigation, NVIDIA was found to have violated the anti-monopoly law of People's Republic of China and the announcement of State Administration for Market Regulation on the anti-monopoly review decision of approving NVIDIA's acquisition of equity in Mellanox Technologies Co. Limited with additional restrictive conditions. They are not big fans of commas. Whew. We got through it. Full stop. The State Administration for Market Regulation decided to conduct further investigation into it in accordance with the law, end quote. Now, both governments right now are using NVIDIA as leverage in this kind of battle between them, which makes it difficult to take anything said by the US or by China at face value relating to NVIDIA, but Let's just look at what the reasoning is. The SAMR approved NVIDIA's nearly $7 billion acquisition of cutting-edge networking company Mellanox in 2020 on the terms that NVIDIA would comply with 6 conditions. We machine translated those and then paraphrased them for brevity. The first is no forced bundling of NVIDIA GPUs with Mellanox networking devices. They can't hinder customers from buying them separately, and no discrimination against customers who do buy separately. The second is to continue to supply NVIDIA solutions to the Chinese market fairly. Third, ensure interoperability between NVIDIA hardware and third-party devices. Fourth, maintain the open source commitment of Mellanox's communication software. Fifth, protect the information of third-party accelerator and network device manufacturers. And sixth, the conditions apply for 6 years following April 10th, 2020, after which NVIDIA can apply for the restrictions to be lifted. The Chinese SAMR has not indicated which of these 6 conditions it thinks NVIDIA has violated, or if it's multiple of them at this point. Our guess would be that it's the second one, which is continue to supply NVIDIA devices to the Chinese market fairly, because the US government has stepped in and has restricted the export of those devices. So whether that's caused by a third party acting on NVIDIA or not, that seems like it would maybe apply here. On one hand are its terms with SAMR, though, NVIDIA's, and on the other hand are its obligations to US export control restrictions. After all, NVIDIA is a US company. However, NVIDIA also relies heavily on Chinese companies, both for production of its products and for money. The chips themselves are produced by TSMC in Taiwan, but almost all the downstream process is in China. NVIDIA made 13% of its total sales from the Chinese market in 2024. NVIDIA's networking products are an incredibly valuable part of its overall data center business as well, and easy to overlook. It's these solutions, including the Mellanox ones, that allow them to connect clusters of GPUs as effectively as NVIDIA does. It has a genuine advantage there. Now, we're looking around a little bit for motive here, and Chinese companies are also currently investigating their own networking solutions to deploy that would compete with what NVIDIA makes right now, as far as we understand it. So maybe there's some additional motive there, in the same way that the US is effectively slowing business in China with its own export control restrictions. Seems like they're basically both trying to figure out how to cause the most harm without going too direct and overboard with it, I guess. I don't really know. NVIDIA, look, NVIDIA's in between a rock and a hard place. We're just not sure which one is the rock or the hard place between China and the US. But the reason NVIDIA's there is because there's lots of money there. That is where all the money is right in between the rock and the hard place. And so far, they've done a pretty good job at extracting it. There's probably a fence there that NVIDIA is constantly playing. They are playing the fence, and that's where all the money is, so I guess that's why they're doing it. Now, anyway, if the SAMR finds NVIDIA in violation, NVIDIA could face enormous fines, representing a portion of its annual sales from the previous year. NVIDIA responded with a statement to Seeking Alpha, quote, "We comply with the law in all respects. We'll continue to cooperate with all relevant government agencies as they evaluate the impact of export controls on competition in commercial markets," end quote. The U.S. Treasury Secretary called this development, quote, "poor timing," end quote. SAMR's investigation comes on the back of the roller coaster of tariffs imposed by both countries and pressingly trade talks that are ongoing at the time of publishing this. Just as some conjecture here too, it seems unlikely that China would completely ban NVIDIA devices until it has its own domestic supply fully operational and competitive. Right now, that is not the case. They have kind of picked and chosen which components to ban or which of their own companies to restrict on the purchasing of NVIDIA devices. We understand it so far, but there has not been a blanket ban. And if you want to see more of these topics, you can check out our GPU smuggling documentary. It is fascinating in sometimes the worst ways, but also there's some real innovation there too, and we've got that linked below. So we'll have a standalone piece, additionally, just as a separate note, covering the EA acquisition on our GNCA channel. I think that's enough of these types of topics for this week for hardware news, so we're going to put that one over there on GNCA as a standalone. There are some additional hardware news topics. This one's pretty interesting. So 5 years ago, we covered an x86 CPU from Chinese CPU manufacturer Zhaoxin, a company whose name roughly translates to mega core, or trillion core if you prefer. These were interesting for being x86 and were made in collaboration with VIA, a rare x86 license holder and also an investor in Zhaoxin. Back then, 5 years ago, we covered its early CPU products and tested them in a pre-built machine. They weren't that good, but they were making some progress. It also contains a history section on Zhaoxin if you're curious about that. Patrick wrote that piece. It is excellent. This past week, Zhaoxin has announced its newest KH-50000 series CPUs. That's the name of them, 50000, not to be outdone by the paltry 3-digit naming from Intel and the whatever the fuck this is from AMD. No, Zhaoxin has 5 full digits, and its new CPU takes a familiar chiplet approach. The photo of the delidded 96-core part shows 12 chiplets and a large I/O die in the middle. In some ways, this is familiar to AMD's EPYC CPUs. However, AMD orients its chiplets differently. They're adjacent to each other directly and contacting one another in their respective groupings. The Zhaoxin website says that this server processor scales up to 96 cores, 384 megabytes of L3 cache, has 12-channel DDR5 ECC, 128 PCIe Gen 5 lanes with notation of CXL and ZPI, and 16 lanes for lower-speed PCIe Gen 4, USB, and SATA devices. Zhaoxin says these can scale up to quad-socket systems at 384 cores. The top spec listing for the page says frequencies up to 3 GHz boost, and critically notes support for x86 3264 instructions. Tom's Hardware also pointed out that the size of this CPU is similar to that of modern AMD EPYC CPUs. Up next, AMD marketing. The most terrifying 2 words that can be stated, because you never know what direction it's going to go. It's kind of like you almost need supervision when these words are stated, just to make sure AMD doesn't accidentally walk off a cliff or somehow hurt itself. AMD's Chinese branch appears to be marketing some of the X3D CPUs as being capable of 1000 FPS gaming. Now, this comes from a single slide shared by RealVictor_M on Twitter. PC World received word from a US-based AMD representative that it, quote, appears to be genuine, end quote, but hasn't been fully authenticated. Taking it at face value, the slide shows that the 9800X3D, 9950X3D, and mobile 9955HX3D, which is definitely a name, are all capable of hitting 1000 FPS at 1080p in 6 games, including Counter-Strike 2, League of Legends, Valorant, PUBG, and Marvel Rivals. There were 3 test setups. The first 2 had a 9800X3D paired with an RTX 5080 and an RX 9070 XT. The third had a 9950X3D and an RTX 5090D. All used a DDR5 6000, ran Windows 11 24H2, and had Smart Access Memory, or SAM, and Virtualization-Based Security, or VBS, disabled. The 9070 XT system only hit 1000 FPS in 2 of the games, which makes sense considering it's not as powerful as the 5080 or the 5090D. Now, this doesn't mean much in a practical sense, considering the frame rate of these games is entirely dependent on how they're tested, what scene it is, where they're tested, what settings are used, things of that nature. Hitting 1000 FPS is also not the same as running at 1000 FPS, because you can, in Counter-Strike, you like point at a skybox or something, I guess, and get a pretty high frame rate. You could find scenes where they are lower intensive workloads, especially if there's no active combat or anything, there's a lower model count on the scene, something like that. So anyway, point being that it's possible to hit a high FPS like this without it actually manifesting in an as meaningful way for the end user. But I guess as a marketing gimmick, this is fun for AMD now. And to be fair, the CPU side has earned it. It's normally the GPU side that needs to shut the f up. But the CPU side, they've earned a little bit of this gimmickry. Maybe related, a couple companies have talked about intentions to produce 1000 Hertz monitors in the future, including Ant Gamer and TCL, which actually had a functional prototype at Display Week 2024. Apparently there's a convention for everything. Intel is mid-rollout on its Battlemage Arc Pro workstation GPUs, and it's actually going pretty well. We've rolled a few stories into one for this, so the B50 GPU is one of the best-selling GPUs on Newegg right now for workstation cards in its class. The B60 is launching soon, and then Maxon's dual B60 GPU with 48 gigabytes of memory split between the 2 GPUs is also coming out soon. So first, the reception is starting out warm for business casual Battlemage. Found via Reddit, the recently launched Arc Pro B50 is now the top-selling workstation GPU on Newegg. It's currently $350 with 16 gigabytes of memory and has been on and off backorder this week. The B50 can be thought of as a slightly cut down B570 with 2 fewer Xe cores, reduced core frequency, and a lower board power at 70 watts, meaning it can run without a power cable. Notably, the B50 has 16 gigabytes of GDDR6, which makes it stand out from its competitors. NVIDIA's 16 gigabyte workstation options cost $700 or more. Second, the B50's higher performance counterpart, the B60, should be launching soon with an MSRP of $500. Its hardware configuration is similar to the B580, featuring the same Xe core count at 20 and the same matrix and vector engine counts at 160. Its board power is also configurable from 120 to 200 watts, which is 10 watts higher than the B580's 190 watt board power baseline spec. The huge difference will be the B60's 24 gigabytes of VRAM versus the 12 gigabytes on the B580. That, combined with the $500 price, makes it viable for VRAM-limited situations, like local machine learning or so-called AI training and inference tasks, and some 3D and video rendering tasks. If the B60 actually launches at $500, we think it'll be in demand for business use cases where speed matters less than capacity. NVIDIA still has the advantage of CUDA being the de facto standard in GPU compute, but its competitors and the open source community work constantly to provide and improve alternatives. Thus far, though, there's really no replacing CUDA. It is dominant and it works well, and that's a legitimate advantage that NVIDIA has in the marketplace. I mean, even down to, again, the stuff we do, like rendering things or working in Blender, using CUDA acceleration is generally a pretty big advantage for speed. The most interesting of all is Maxon's B60 Dual 48G Turbo. We covered this one previously and took it apart back at Computex, so you can check that out for more, but its specs are now final, and its board power is at 400 watts with a 12-volt 2x6 connector, and it requires PCIe bifurcation on the motherboard. It's rumored to cost $1,200, according to Video Cards reporting on a now-deleted Reddit post, but Maxon's page only has a button to request a quote. There's a lot of Intel news this week. Intel's ramping for something, it seems like. So Intel is hard at work preparing for the launch of Panther-like mobile CPUs, and that means there's some new GPU news for its Xe3 architecture. And Phoronix reported on a recent patch merge from the team working on Mesa 3D drivers for Linux that reportedly gained roughly 4 to 9% in game performance. In the merge, one of Intel's engineers said, quote, "This series addresses a number of compiler-related performance problems that would have affected Xe3 platforms and led to less than ideal performance in most GPU workloads," end quote. According to Phoronix, the patches focus on scheduling and thread parallelism optimizations. Now, Intel has previously announced its roadmap containing a Celestial GPU after Battlemage. Xe3 likely won't be a perfect representation for its eventual Celestial discrete desktop GPU architecture, as Xe3 will be built for mobile deployment, and there could be some structural changes between the two. Still, it'll be the next step towards the eventual C-Series launch on desktop. Another contributor submitted performance benchmarks as graphs, comparing baseline versus two different implementations of the patches. They said, quote, "Here's the result of my real game testing. Cyberpunk was excluded because of GPU hang issues. Borderlands 3 saw some periodic hangs, but I was able to collect. Warhammer results look strange, but I did verify them with a second run," end quote. The best result was an 8% uplift in Black Myth Wukong's benchmark. Others had no meaningful change, and Total War, Warhammer 3, and Vulcan showed slight regression in one configuration. The improvements seemed to come at the cost of shader compilation time, shown in another graph, increasing by roughly 25% in some situations. We aren't sure if that would appear in the pre-launch shader compile time that's become very common in modern games, or if it's something that happens while the game is actually running. Now, this is all pre-release, and it currently only applies to Linux in the Mesa drivers. Panther Lake is allegedly on track for a launch this year, and Acer has stated that its laptops will likely take until 2026 to come to the market. That's it for hardware news this week. There's a lot to catch up on. We've got some cool stuff as always coming up. Really excited for it, so check back, subscribe to the channel to catch all that. And go to store.gamersnexus.net to support us directly, or patreon.com/gamersnexus to throw a few bucks our way. Thank you for your help. Thanks for watching. We'll see you all next time.